Okay, now we're dealing with scaffolding. We've dealt with other areas of working from elevations, such as ladders and stairways, and now we're dealing with scaffolding. So scaffolding is the skyhook. It's the way that you can work at some elevation that normally wouldn't be possible comfortably and safely. When scaffolding is set up right, it's a very safe way of working at elevations, especially compared to working off of stairways or working off of ladders or suspended in a class 4 harness. I mean, you just think about the ways pogo sticks. Well, no pogo sticks. Okay, let's see. In dealing with working from the different fatal 4 fatalities in construction, there's falls, struck-bys, electrocution, caught in or between. And we're dealing basically with working from elevations, protecting from falls. Okay, so now we deal with, here's what basic scaffolding looks like, something like this. And remember that the standards for scaffolding in construction would be subpart L. It's 1926, 450 through 454. This will help you if you're doing with those assignments. Now here's kind of the anatomy of scaffolding. You've got a fully planked deck or decks. You've got maybe an access gate, or you could have an access ladder. Remember that you never use step ladders to climb up onto scaffolding ever. There's guardrails and toe boards, top rail, mid rail, toe board, and they can be in different ways. There's cross bracing is critical, and I don't see it here. All there is, it's just not labeled diagonal bracing that keeps the thing rigid horizontally. The cross braces keep it rigid vertically, and we've got to make sure the thing is plumbed vertically. It's got to be sitting on a good foundation, what we call a mud sill, and then you've got base plates that are attached to that. Or you could have wheels instead, but then if you're doing that, you're going to be rolling around on a good, solid, strong concrete slab or other pavement of some sort. So here's better anatomy. This is kind of showing these components from the step frames on each side to the diagonal braces in between them that hold, and that's the basic structure of scaffolding. And then you should have a diagonal brace that we call a catacorner brace across diagonally at least once, ideally 2 ways, and so that you can make the thing rigid in that way also without relying on other means. And then for stability, if you're going to go up higher than a 4-to-1 ratio, you definitely need outriggers to keep the thing stable, and maybe in more directions than they show in this picture. But because especially when you have wheels, you're required to have outriggers. If you're going to roll somebody around on it, and you say, that can't be done. Well, OSHA does allow it as long as you're only going as high as a 2-to-1 ratio, and then you've got the outriggers also. So that's getting into the weeds, but all these are components, and you can come back to look at them. Some of you know all about these because you do scaffolding, but I started to list the parts here on the side. So what is scaffolding? Well, it's an elevated temporary work platform. There's 3 basic types. The ones we've been looking at right now have all been supported scaffolding, like what you see in this picture. But what you see in this picture is not done properly. I'm showing you actually an OSHA file photo before somebody got cited. You can't just pick and choose what planks you want to lay down. And that's what I grew up doing and before I got working in actual plants. And that is just, you set up the scaffolding by guess and by golly, and you use a few planks. But you're supposed to fully deck every level, not like what you see here. Heck, we used to climb from plank to plank on different levels, and you alternate the planks from level to level, and that's kind of a hinky way of doing things. I need to backtrack a little bit. This is supported scaffolding, type number 1. Number 2 is suspended scaffolding, and we looked at that a little bit in the fall protection area. And then the third category that's under scaffolding in the OSHA standards is aerial lifts. And some of you may say, well, that's not scaffolding. Well, it's a scaffolding substitute, but this is where OSHA chooses to put it. So aerial lifts such as cherry pickers or boom trucks or scissor lifts, they're all scaffolding, mechanized scaffolding, I guess you'd call it, in that category. It fits in there toward the end of their section. And NCCR covers it this way too. So this, I guess you'd say, is mechanized scaffolding. Hopefully not. I would say that's not something that you want to try on your job site. Nothing ever comes good of making things out of pallets. Pallets are the cheapest of wood that you can buy, and they're meant to be a disposable item for shipping things, not for making anything life-saving. So no, this is not a thing. And then this is not a thing either. A pallet used as a man lift or a personnel carrier lift support system. You can buy and use special personnel lifts that are mounted to the scaffolding, but they can't just be slid on them or zip tied with plastic zip ties like they've done here. They need to be chained and clamped to the forklift so they can't slide off either. But here these guys are just trying to hang their insulation before they put the sheet metal on the outside. This was right on campus when I came down to look at some structural steel, and they say, "Oh Lord, what do we have here?" So I had to take pictures of it. I don't think they ever noticed I was taking them or cared. Here's an impressive scaffolding project. I've got quite a few in here just for show and tell today in this one. But this is the Statue of Liberty, of course, 305 feet from the ground up to the top of the torch. So back when they did this big project, it was a project that took 3 different scaffolding companies combined in order to do the work. Looking a little closer, it's still very blurry in this picture. Maybe I can find better copies nowadays, but this is all I could find when I was looking. But in here, you can see the torch, and they've actually got an elevator. And this is very common in very extreme tall scaffolding projects like this, to have an elevator built into the scaffolding as they go. Here's another impressive one. You know, they had an earthquake near Washington, D.C. area that caused some serious cracks in the marble on the side of this monument, the Washington Monument, 555 feet tall. Man, it's something. 555 feet tall. That's a lot. But anyways, they scaled this thing coming from top down in order to examine more closely the cracks, but nowadays they would do that with drones. But anyways, made a very impressive structure around it as a scaffolding system. So it's just about as impressive as a monument itself, hey? Bracing it to the monument. So sometimes you can't brace to the structure. Sometimes you can tie to it. Here they were able to. Otherwise, you'd have to have something else to make the structure rigid. So here it is, all lit up at night, looking pretty impressive as a scaffolding project with the elevator you can see from the profile. Another impressive project in the same neighborhood was the Capitol Dome. You know, the last time they refurbished this thing at all was a sandblasting back in 1959 to 1960. So in about a decade ago, they did a new refurbishment. At that point, there were 1,300 known cracks in the cast iron dome. Yes, this is a cast iron dome. Now, this is an artist rendition of this thing, but here is the actual scaffolding in place, doing what they do. So they're repairing all those 1,300 known cracks and finding more, I'm sure. Anyways, you notice the screened in area here. This is probably the most they're allowed to screen this thing in order to be safe. You know, you screen in an area, maybe they're able to heat the area and sandblast it and contain the sand. Maybe they're able to paint it during wintertime by heating the area because of that in cold weather. But if you were to screen in more of this, you could end up turning the whole thing into a big old box kite. And that is the big danger of screening in scaffolding. You've got to know how many square feet can you screen in, or what shape does it have to be, and that sort of thing. By the way, you can't set up any of this scaffolding that I'm talking about on these huge scales like this without a structural engineer being involved, a specialist that deals with this. You'll use scaffolding that's manufactured, but this is beyond any instructions that would be in here. Just look at the base. There's no going to the ground with this thing. They had to somehow attach and support it by the structure itself. So that requires engineering and permissions and all kinds of things to do that, to think that through. And then to make this thing so it's going to save, that nobody's going to get hurt, that this thing isn't going to collapse. It takes an awful lot. So you definitely don't do this by the seat of your pants. You need a structural engineer or a whole structural engineering firm involved. Here's some more impressive scaffolding here. I did not a great picture of it, but it shows some details. But sometimes these structures do fail. Sometimes they don't get it right. Sometimes it's the engineers, but a lot of times it's the contractors going and trying to go cheap in how they do the work and how much oversight and how much inspection. And sometimes it's because of the schedule that the installers are having trouble here. So with that, here's one that killed 74 people in China in 2016. Just some of the aftermath, and I don't have a lot of detail on this one. But in this next one, this one happened in downtown Houston in 2015. Now, I'm not sure if this will show up. I'm going to try it. So I'm going to click on my video and see if it works. So this happened in downtown Houston, right across from Minute Maid Park, the home of the Houston Astros. And the video you saw was actually recorded by a tourist who was filming his family and suddenly pivoted to take that motion in as it all came. So it came down quick, like dominoes, like a house of cards. The rescuing, there was nobody that died in this thing. There was a bunch of people on that scaffolding, and somehow they all survived. There were 6 people that went to the hospital. But there were 200 people working on this building, and so some of them were on the scaffolding that survived and didn't need to go to the hospital, and some were inside the building itself. 6 workers injured when the scaffolding collapsed. It was a 7-story building, so there were 7 stories of scaffolding too. Leaving debris scattered all over most of a city block. There were 2 companies that were cited by OSHA for not doing the right thing with scaffolding techniques and not initiating a safety program. And so basically the masonry company that was dealing with the scaffolding and also the general contractor also. So, just amazing. And this is the thing, is sometimes things can go just right enough that people survive, but it still becomes a big deal, especially when these scaffolding projects, they're often around populated areas and there's plenty of cameras. Now, this one was surprising that there wasn't any other cameras that picked up this accident other than this German tourist that picked it up. But 100 firefighters responding. A lot of them were looking through the rubble trying to find survivors. Sometimes the high winds are the problem, like I mentioned before. So here's an example of scaffolding that was blown over. So it would have been tied to the building, but it wasn't strong enough to take the force of the wind. Wind can be tremendously strong, especially over large areas. Here's some more scaffolding collapses. One is in Illinois and the other one in Norway, showing this. So the one on the left is in Norway at an apartment building, and it was just hanging in there, blowing like a sail. And then this other thing all came down in Rockford, Illinois. Here's another one. I think this one was in England somewhere, or in Britain somewhere. And here's another one, I think, from the same windstorm in Britain. So more typically, not talking about scaffolding disasters as far as wind, but more typically, you've got homemade scaffolding in residential sites like this. Job site made. And this is not allowed, but it is done all the time in every residential project, neighborhood that you see where there's lots of homes being built. No guardrails, just like something out of Dr. Seuss. And this is not allowed. And the only reason they get away with it is there is way too many sites for OSHA to catch up with. There's far more construction sites in this town in residential construction than there are OSHA inspectors in this town by an order of magnitude. So yes, they happen and they get away randomly, but plenty of them do get cited also. Okay, I forgot I blew it up. There it is. There is a team effort of some kind. It's not really scaffolding, but they should have scaffolding. If anybody needed scaffolding, it's this dynamic trio. And there's a trust-based scaffolding, of buddy scaffolding, I guess you call it, where you got to trust that those three will stay there and not leave their post. So things happen all the time, falls from elevation caused by slipping, unsafe access, the lack of fall protection, struck by falling tools or debris. So people climbing underneath or walking by scaffolding can be struck by stuff. Electrocution from overhead power lines. Most of the scaffolding is made of metal, which means that it conducts electricity. So if there's ever any contact with high voltage lines, that always ends horribly. But also, it can happen from just inducing a current within the scaffolding by being nearby and within the electrical field of the high voltage lines. So you don't have to be contacting power lines to end up inducing a current in the scaffolding, especially if you're on dry, fairly well insulated mud sills. You get a small percentage of the electricity induced into the frame, and then when you're standing on regular ground and you touch the scaffolding, you get electrocuted. And then, of course, with rolling scaffolding, that's the greatest chance of being electrocuted, because you're rolling the stuff around and people just don't tend to look up when they're pushing things around or moving things around. Of course, bad planking can give away too, and so that can cause the problem. So here's some supportive scaffolding that's certainly not being used properly, not set up properly, and they've gone off the field of the scaffolding with a plank onto some support of concrete there. But again, while climbing on and off the scaffolding, working on unguarded scaffolding platforms, or when platforms or planks fail. Then there's something called ladder jacks that they mount to extension ladders, and then you can put a plank across there and you've got instant scaffolding, right? Well, how do you employ any kind of fall protection here? You just can't. So no, this is not allowed. I have a couple of pair of these at home still. If anybody, I don't want to give them away to anybody I care about though. Okay, so what the caption is on here, and this is important, there's two things. If a worker on a scaffolding can fall more than 10 feet, they must be protected with fall protection. So you say, what? I thought we had a 6-foot rule. Yeah, well, scaffolding has its exception, and their exception is that anything more than 10 feet with scaffolding must be protected with fall protection. So you need to know that number. 10 feet is the rule for scaffolding. Even though if you've worked in the plants, you would never follow that rule. They would have a much stricter rule, maybe a 0-foot rule even. But fall protection can consist on scaffolding of guardrails and or a personal fall arrest system, PFAS, or safety nets. Any of those three, OSHA says, is a form of fall protection that is acceptable. So here's some lift scaffolding, where literally they pump it up, they can raise and lower it, sometimes mechanically with, automated mechanisms, and sometimes with pump jacks or more manual. But with things like masonry work, you typically start at the bottom and then you work to a point where you need to get some scaffolding, and then you start needing to go higher and higher. And so sometimes they do that with a lift scaffolding system of some kind. But it should be fully planked. It should have full guardrails, including toe boards. So you don't see toe boards on this one. And the reason is, and you should have a top rail at 42 inches, a mid rail halfway between, and the toe boards at least 3.5 inches high. There's no toe boards on this thing. And so why is that? Well, probably because they want to take a forklift and bring up some masonry and slide it on in and remove some guardrail in a little section so they can slide it up with a forklift. And the toe board's just getting away. Well, OSHA doesn't care. You have to have toe boards, because otherwise you can be launching tools and pieces of masonry and whatever else off of there to people below. And of course, you shouldn't have people below, but you still have to act as if there will be people below, because after all, you got to be below when you walk over to climb up on this thing. So a mud sill is your foundation, and it's normally required to be a combination of lumber components or something like this. So this is very, very common to take solid wood and then join it with plywood, because plywood doesn't split, because you've got veneer running in two different directions, well, multiple directions, but 90 degrees from each other, each layer of veneer. And so when a combination of all that is constructed, you have something that won't split. And so this becomes like the snowshoe. You know, to walk on snow, you have to have a snowshoe that spreads the weight over an area if you're going to be on top of the snow. Well, to be on top of the ground, you got to distribute your load over a big area. So depending on the weight that'll be on this base plate, on this leg of the scaffolding and the base plate, you might need a bigger mud sill, depending on the quality of the ground you'll be sitting on. So it depends. I can give you some ideas, but like the adult diaper, it depends. Okay, I know, bad joke. Trying to keep you awake. What you should never do is what you see in this right-hand picture, is use masonry block for a support of any kind of structure, including jacking up your car. You can, but certainly not support. You should never support scaffolding with masonry block. There's nothing wrong with a masonry wall where you've got concrete and rebar inside the wall, and that's a solid material that could be considered structurally sound enough with, you know, the advice of a structural engineer to use. But when you're talking about loose masonry block, they're like pieces of glass. They can shatter at any moment. In fact, you can see that all around you, broken up pieces of masonry block. Half of them are broken in this picture. So platforms must be fully planked or decked with no more than 1-inch gaps, because if it's more than a 1-inch gap, from 1 inch up to 12 inches, is considered a floor hole that you could trip on or drop something through. Be able to support at least its weight and 4 times the maximum expected load. So whatever load you expect you're going to put on here, you've got to make sure that the scaffolding that you use is strong enough to support that and its own weight and 4 times that load. Minimum for scaffolding is 18 inches. There is no such thing as something called scaffolding if it isn't at least 18 inches wide. But 18 inches wide is pretty narrow scaffolding. That's the kind of thing you might use in your house for inside work, you know, rolling around to paint walls. And remember that no higher than 4-to-1 ratio on the width. And so 18 inches times 4, well, let's see, 18 times 2 is 36, times 2 is 72. So you can get scaffolding that's 18 inches wide. You can go no higher than 6 feet. Unless you stabilize it with guy wires and braces of some sort. So, going on and on, yeah, the picture on the right-hand side is another poor example of scaffolding, because they don't have it fully planked. All they've got is this individual planks on different levels, and that's not acceptable. Not a properly constructed scaffolding. Now, here's some more scaffolding. You're not supposed to have large gaps, no more than 1 inch between the boards. They need to be fully planked across with of course, toe boards and guardrails and such at every level that you're going to plank. And then what you see down at the bottom here of this lower picture is you got a plank on top of a plank. They have to be over bearers. Each one has to be supported by a bearer, by a bar. So you need a 12-inch overlap if you're going to overlap, and they've got to be restrained so they can't move sideways, move back and forth at all. That means having scabs or such that can hold them in place. No paint on the wooden platforms, the wooden boards that you don't see in this picture, but in the previous picture you did. You cannot paint them. You got to use scaffold grade wood, fully planked between the front and upright and the guardrail support. The component pieces of your scaffolding system used must match and be of the same type from the same manufacturer. That's enough to get you in serious trouble in lawsuits during any accident. You got to erect the scaffolding on stable and level ground. If you've got wheels, they've got to be locked. If you've got, well, you'll have braces for sure. They got to be locked in place. So you make sure everything is locked up in place. Remember the scaffolding height, I mentioned the 4-to-1 ratio. Unless you have guy wires and braces, then you can go higher. So that's how they're able to go to much higher elevations. But this 4-to-1 ratio is, for example, a very standard size of width of scaffolding is 5-foot scaffolding. That's very common. So the 5-foot width means that you could go 20 feet high. 5 times 4 is 20. If you've got a stable ground. So there again, if you don't have stable ground, you'd have to use guy wires and braces to stabilize this stuff, even at a 4-to-1 ratio or less. So again, it's still a judgment call. You got to have a good, solid, strong foundation. That's the mud seals, and then you build up from there. So here I was at Albertsons years ago. I don't remember what year now, but it's probably 7 or 8 years anyways, that I came across this scaffolding that's only 2.5 feet wide, 30 inches, and it's going up about 28 feet. So good high scaffolding, and it's way beyond. Let's see, 2.5 feet. Let's see, that 10 feet is as high as you could go with this scaffolding normally, at 2.5 feet wide, without bracing. Yeah, if you have an ideal surface to mount it. And they got a pretty good surface to mount with that concrete that they were on. But that said, they only had, so they were going beyond the height. They got to have guy wires or braces. They had 2 rebar wires set up, one at each end, tied to a screw that was screwed into the wall. So it was nowhere near adequate. So I started taking pictures, and the next thing you know, the manager would come out to look and ask, trying to figure out who this guy is, me. And I explained that, this is just kind of an unsafe condition. I was taking pictures. Oh, well, I have nothing to do with it. It's all the head office. So everything is about deflecting blame here. But basically, they had a more than an 11-to-1 ratio instead of a 4-to-1 ratio with this scaffolding here. And 2 guy wires that they had. I think I got the picture right here. Yeah, so on the right-hand picture, you can kind of see it above the Chase sign here, what they had here. And it really wasn't fully planked either. You can see lots of gaps that were bigger than 1 inch. Anyways, just kind of a fun picture to take. Here's an end of the platform. It's not cleated. That's the word I was looking for. That if you want to keep these boards, and if they're not giving you at least 6 inches beyond the support, you've got to cleat the thing so that they can be kept in place. There's lots of rules in scaffolding. I know some of you have experience with scaffolding and know way more than I do about it. But it's an art and a science, and such an important part of the job site safety to have good quality scaffolding set up properly. Not like this. Look at this so-called mud sill, hey? I mean, you could have arguments about whether being on structurally sound concrete slab might be acceptable all by itself. And, certainly I would make that argument, but not this. He missed it, of course, and he took whatever he could reach within arm's reach to put down here. You got to be restrained from tipping over by guy wires, ties, or braces. Okay, here's some more pallets being used in ingenious ways, but OSHA would freak out about this. In fact, I guess they did, because this is an OSHA file photo that I stole from them. So they got cited for this one. You're not supposed to climb those diagonal braces, so that's a big no-no, and it came from OSHA too. Suspension scaffolding. Okay, I talked about it a little bit in the fall protection area, and I'm coming back to it again here. Just a couple of things to point out. Normally, with the strength of ladders, of scaffolding, we need to be 4 times stronger than what you need, 4 times the expected load. But in these suspended platforms, they go with 6 times the expected load, so they have a higher safety factor, because there's no room for error. When these things collapse, you're in trouble. Now, looks like neither one of these people on this suspended scaffolding have any form of fall protection other than a board running across. They got a top rail. They don't have a mid rail or a toe board even. So they got very little to go by. So this is an OSHA file photo. They got cited for sure. On this picture, I had this in the fall protection chapter also. One person's tied off to a proper lifeline, like the independent lifeline, like they're supposed to, not tied off to the guardrails. And so one survived, one didn't. Okay. And here, I showed these pictures before at Our Lady of the Lake Hospital. In 2013, they had an incident just like this, except that everybody survived. So this was the suspended scaffolding after they rescued, and it was how it was dangling. But the original picture, you just look up here and you can see two people. Well, there's actually three of them there. And when I go in a little closer, you can see that there are three people that were on this suspended scaffolding, and they're all alive because of the fall protection that worked. And then they hoisted them up very quickly, so there's very few pictures. I had to find these all on social media and steal them from the news, where they got them from social media back then even. But anyways, with that, notice how much force or how much compression there is on the guy's legs here in the center, where you got a pretty good shot of the pelvic straps, the leg straps, and how they are putting so much pressure on his legs. This is called suspension trauma, and if you're left dangling for an hour, you're going to be in serious trouble. You really shouldn't be in this position for more than about 10-15 minutes tops. So that means that your company has to have a plan in place and ready to execute when anybody actually ends up having to use the fall protection. They're actually being dangled by this thing, so they can be saved within 10-15 minutes tops. Because the toxins that build up in the blood, the clotting that can develop, all can be life-threatening, seriously life-threatening, especially about right after you rescue them. That's when everything goes horribly wrong. And so you think you've got them saved, and next thing you know, they pass out, and maybe they wake up dead. Okay, bad joke, not a joke. But the point is, they were able to rescue the two that are out here in the middle by taking them up through the windows. They were installing windows at the time, and so the guy in the orange was saying that he was actually holding on to the glass, had the weight of the glass on his personal fall arrest system as he fell. And, you know, it's just as likely that the guy that's over with the superstructure could have been tangled up in the superstructure and had the weight of that superstructure. So that's the reason that we are so required to be tied off, where every element within our personal fall arrest system has to be able to support 5,000 pounds for each worker attached. It's because you can be holding more than just your weight on your lifeline, on your lanyard, on your tie-off point. And then I noticed that there's a couple of people peeking through the window at their buddies here from inside the building. And here you can kind of see them too, as they're dangling. So the guy that was with the superstructure, he had to be hauled all the way to the roof, whereas these other two, they were able to bring them in through the windows that they hadn't finished installing yet. So, moving scaffolding. You are only allowed, in general we say no riders on the scaffolding, so you should be getting off the scaffolding before you move it, if it's on wheels. However, OSHA doesn't say absolute no. What they say is the height to base ratio has to be no higher than 2-to-1, and you must then also install outriggers on both sides of the scaffolding. In this picture, they do have an pair of outriggers on one side of the scaffolding. They need another pair. So my guess is as they were getting close to the wall, they wanted them out of the way so they could get closer. So they may have just taken them off at that point. I don't know. Trying to be fair, but otherwise the employees can't be on the scaffolding beyond those wheels at all. Okay, so even at that, a 2-to-1 ratio here, and they are too tall. So remember, this is 18-inch scaffolding, so you can go up 6 feet. I would say they are definitely higher than 6 feet in this picture. Okay, competent person must be on site to supervise scaffolding work. So now we're looking kind of at the extendable boom platform and how it was working. The boom was fully extended, and the machine apparently ran over some bricks, causing a boom to flex or spring, throwing the employee from the basket to 37 feet to the concrete below. So yeah, this was a fatal accident where the person died. So when you're in a work basket of some kind and you work up to some elevation and you decide you're going to climb out of that work basket, that sometimes is allowed, but you've got to be able to tie off to something else. You cannot use home base. You can't use that work basket as your tie-off point. It also means you need a second lanyard so that you can continue to be 100% tied off the entire time, so that when you connect onto some new tie-off point, you do that first and then you disconnect from the work basket as you climb off onto the building or whatever. So do not make your anchorage point the same as a work basket tie-off when you are leaving the basket, is what it really comes down to. Now, when I was in my carpentry apprenticeship, at age 16, I started a carpentry apprenticeship and became a journeyman carpenter. But in that training, we learned how to make what we call lean-to scaffolding. It's kind of like the half of a sawhorse cut in half and leaned against a building. You can kind of see there's a 1, 2, 3, 4, 5. There's half a dozen of them here leaning. There's 3 on the ground, and then they built another smaller set that they sat up top. And then they lean them against the building, and they rely completely on the friction with the ground to not slide away. And you can put planks up there. Oh, no. I remember thinking I would climb up on this stuff that we had built. What happens if it slides out? Oh, take it up. Put it out of your mind, Gary. Keep working. But in reality is that it's a horrible thing. And OSHA says emphatically that you shall not ever use lean-to scaffolding ever again. So do not speak of it. Do not do it. Anyways, it's not a thing anymore. So if you ever see somebody bring that thing out, resurrect the idea of lean-to scaffolding, or shore scaffolding, they sometimes call it. No, you cannot do that. Screening it in. Now this stuff is semi-porous, and that is something that can allow you to screen in more scaffolding. So, but you still have to pay attention to how much area you are actually allowed to cover in because of the wind load considerations. You don't want to turn your scaffolding into a big box kite that blows around and becomes airborne. Or worse. Fatal fact, ice and no guards. So you got somebody on icy scaffolding and slip sliding, and not enough places, some places that were not fully guardrailed in. So this worker slipped and fell headfirst 20 feet to the pavement below. So everybody that's working with scaffolding has to be trained. And you have to have a competent person who is the expert and in charge on that site at all times. You can't set it and forget it and let people untrained work on this stuff. You have to have qualified workers, and you have to have somebody who's in charge, who understands how to solve problems. And then we determine them, we call them competent persons when he or she has that training and that expertise. That means that you can't repair scaffolding. If it's damaged, you should take it out of service. This is not a proper repair. So scaffolding can only be erected, moved, dismantled, or altered under the supervision of the competent person. The competent person selects and directs these workers and determines the feasibility of fall protection. And so it's a very methodical thing to install scaffolding from relative positions of safety. You know, if you've ever heard, this, you understand that there is no such thing as a sky hook. Well, in some ways, the scaffolding is the sky hook that you build so that you can get up there. And then we have scaffolding tags. We talk about these in other places, but, red scaffolding tag, nobody should get on here except maybe the person who's actually building the scaffolding. And because it's a warning that it's not ready for the person to use. The yellow scaffolding can typically be used as long as you follow whatever the precautions are that are listed on the scaffolding. And then green scaffolding means it's ready for prime time. So I've heard in some places that it's not something that you actually use in some plants. You never have a green scaffolding tag because there's always a cautionary message of some kind. But it just depends on the practice of the plant or the site that does this. But you should always heed the color of the scaffolding, the tags. And so the caution tag means that typically you probably can get on it as long as you can comply with whatever the cautionary parts that are listed on that tag are. training involved for scaffold erectors. And then I'm just showing an example of a pretty good system here where they've got drop-down stairs and trap doors so that you can go from level to level and not leave any openings unprotected this way. So that's a good system. You've got to be very careful around high voltage. I mentioned it before. I've got a video that I won't show you here, but it's showing electrocution of 4 people that were pushing rolling scaffolding around, and that was in China. But we had an incident like that a couple of decades ago here in Baton Rouge where 4 out of the 5 people, or 3 out of the 5 people were electrocuted and killed right here just off the airline highway near Corsi in an old furniture building. Very sad and gruesome way to die too, from high voltage lines. Okay, this guy can't decide which way he wants to go. Hey, here's a few crazy pictures I've got in here, and this was a crazy picture of my dear brother Gordy. He had just finished putting all this sheet metal up. He and a son and a helper, they put all that sheet metal on, and this is the only scaffolding they rented. So they had 2 metal planks, had it tied by a rope or something to that column there. And the peak of that roof, you're at 55 feet above the ground. So it was kind of pretty crazy stuff. And I said, well, what about safety harnesses? I said, what's a safety harness? Okay, so he didn't have any idea what that even was. And inside they got pretty tall ceilings too. So they really needed fall protection, and they had none. Yeah, some crazy stuff people will do. Around the world, there are places where bamboo is used. It's an amazing thing to see and all that, and I don't know enough about it to really comment, except to say that I don't think you could get away with doing that in this country because nobody knows how to do it, and certainly don't know how to make it fit into liability and workers' compensation insurance claims, or being allowed to do it. I just don't see it happening. But there's some amazing things you can find, amazing bamboo structures that have been built around the world, probably mostly in China, but around the world there's bamboo is an amazing material. Look at that thing. Oh my goodness. But never hay. Hay is not a thing. You never build scaffolding out of bales of hay. So no. And then I'm not sure this makes any sense either. Whatever they've done here, they've kind of used scaffolding and built a structure on top of it of some kind. You're never supposed to set up scaffolding on top of another platform or building level without involving a structural engineer. And I certainly haven't done it here because all they've got is broken chunks of concrete to level this thing out. That's not a thing. This guy is up here with a couple of planks and such, and no fall protection, no fully decked anything. So no, you can't do that either. Okay, there's nothing wrong going on here particularly. Here's some impressive structures. I can't tell you anything about them really, but the screening in of this structure, if it's been done, it's possible that if you can screen in everything so that wind cannot catch anything, it's possible that this may be something that's acceptable. So it doesn't, there are exceptions to every rule. A lot of it comes down to having a structural engineer involved that understands the forces and makes sure that you're taking care of every detail. And it generally means inspecting it. So when structural engineers get involved with things like this, they have to be fairly hands-on and be there to make sure that things are being done properly. Because they sign a personal guarantee on something like this, they have to be involved in a detailed way. So these things are the basics of the summary for this chapter. The top rail of the scaffolding should be at least 42 inches high, like any other guardrails. The mid rail be halfway in between, and then you've got toe boards at 3.5 inches minimum, at the touching at the bottom, on the bottom planks. Fall protection such as guardrails would be required on scaffolding over 10 feet high. So that is your minimum standard for scaffolding. And so there's a special 10-foot rule for scaffolding, which can throw some of you, because if you've ever had experience in the plants, you know that doesn't fly. But that's OSHA's minimum standard. The next bullet is unsafe to interchange scaffolding parts from different manufacturers. So remember that. That can show up as a test question. And then, of course, just like with the wooden ladders, you never paint wooden scaffolding boards. You've got to keep them exposed so you can look for any possible flaws that develop or crop up. So now we look at that impressive scaffolding. Kind of like onward and upward here. We're moving on to the next topic.